So the slope is 1/3. We've gone up 1 and over 1, 2, 3. If we go up 1 again and we go over 1, 2, 3, our y-intercept has gone from, this is 4, this is 5, this is 6. And so you can write your equation, y equals our slope, 1/3 x, plus 6. I'm a very visual person, and so I like that. However, we need to write it in standard form, so I'm going to first multiply through by 3. No fractions. So multiply through by 3, you get 3y equals 1/3 times 3, which is x, because the 3's cancel out, and plus 6. And then you can subtract the x to the other side, so negative x plus 3y equals 6. Next one, onto a different method. So that was graphically, finding it. Number 10, we're going to use the point slope form. So y minus y1, slope x minus x1. And we're going to plug in, we've got x1, y1, y minus 3. Our slope is 2. So x minus 4. So y minus 3, let's distribute that 2x minus 8. So add the 3 over, y equals 2x, negative 8 plus 3 is negative 5. And again, we're getting it into standard form, so let's move the 2x over here, negative 2x plus y equals negative 5. If you arrange it differently, if you brought the y over here because you really like to have a positive x, it could also be 2x minus y equals a positive 5. And notice that that's just the same, just everything has the exact opposite sign. Alright, let's use slope-intercept form for this one. So what we mean by that is y equals mx plus b. M being the slope, b being the y-intercept. These are the nice ones, especially in this one because it says y-intercept of negative 4, so we know the y-intercept and we know the slope, 1/2 x, so y equals 1/2 x minus 4. Again, no fractions, so we're going to multiply through by 2. So you get 2y. And why I'm choosing 2 is because 2 gets rid of the 1/2. You'd always want to multiply through by whatever the common denominator is. So that gets us back to x, and negative 4 times 2 is negative 8. So again, subtract the x over to get it into standard form, the ax plus by equals c. Just some practice to get us there. So negative x plus 2y equals negative 8. Remember, if two lines are parallel, they have the same slopes because they are going the same exact direction. If two lines are perpendicular, they have the opposite reciprocal slopes. So if it's 2/5, that means you're going to make it the opposite, negative 5/2. The opposite meaning plus or minus becomes the opposite. And then reciprocal meaning you flip it over. Not always do you have a fraction, so you just have to be careful about that. Give the standard form of the equation of the line through point P that is perpendicular. So, we've got a point, and we need to find a slope so that we can make it perpendicular. So let's rearrange this. Y equals negative x plus 4. So the slope is negative 1. So the perpendicular slope is the opposite reciprocal, so a positive 1, because the reciprocal of -1 is +1. And then you can find the equation of the line any way you like. I'm going to, once again, just, because it's graphically and the slope is just 1, -3, 2. If I go up 1, up 1, up 1, I'm going to be at 3, 4, and 5. So y equals 1x plus 5. I don't need the 1 there, it was just, that's what the slope was. I'm going to subtract x over. -x plus y equals 5. And so there's your standard form. Again, you can find it any other way. Parallel to L, if x minus 4 equals 0, you can add the 4 over. And so x equals 4 looks like this. So parallel to that goes through -3, 2, I want a line parallel to that, so it's got to look like this. So this one takes a little less effort because it's got to look like x equals -3. It also has to be vertical, so on and so forth. Alright, so that's a lot of equations, and just to round it off, let's do a quick story problem. Roberto has $22. Buy some notebooks costing $2 each. Let's call that N. And binders costing $5 each. Let's call that 5. Sorry, B. Roberto spends all $22. How many of each does he buy? So, 2N. 2 notebooks. Sorry, notebooks at $2 each, so each notebook is going to cost $2. Plus binders at $5 each, so $5 times each notebook that he buys. So if he bought 2 notebooks, it'd be $10, right? If he bought 2 binders, it'd be $10. And then altogether, he spends $22. So we have to find the one number, the one set that works out perfectly. If you think that all of these binders are always going to be sets of 5. 1 binder, 2 binders, 3 binders. So that's going to be $5, $10, $11, sorry, $15, and $20. And 1 notebook, 2, 3, 4. These are all going to be even. $2, $4, $6, $8. So you can think of this as, well, it's $2 more than 20, and so he's got to get 4 binders and 2 notebooks. Sorry, just 1 notebook because they're $2 each. But he could just get 2 binders and then spend an extra $12 in notebooks. So that'd be 6 notebooks because they're $2 each. Or maybe he didn't get any binders and he bought 11 notebooks. I'm sorry that you can't see that. But all we're finding is, remember, with lines there are infinite solutions. Now, he can't buy fractions of notebooks and fractions of binders, and so there are a finite amount when it comes to all the solutions here. So see if you can find them all. I think we did, but just double check that.